So I'm going to start with setup number 1. So right now, it starts off with the power source being turned off. There's no electricity. There's no magnetic field. There's no nothing. The moment we turn the power on, current, conventional current, goes this way. That's the conventional current, from positive to negative. So this straight wire has a current through it, and with the right-hand rule number 1, we can draw its magnetic field. My thumb's in the hitchhiker position, my thumb points down, my fingers will wrap around the wire, and they will come out of the page in the region of the loop. So how will I describe this? Okay, when power is turned on, current flows through the wire in the direction shown. And we know that a long straight wire with a current through it creates a magnetic field. Using right-hand rule number 1, the magnetic field will be out of the page on the side, like where that loop is located. I'll say in the region of the loop. So as soon as we turn on that current, we will create that magnetic field. And for a moment, that will induce a current into that loop that I've labeled as Y. That'll induce a current into the loop labeled Y. Will that be a clockwise or a counterclockwise current? Well, according to Lenz's law, it needs to resist the change. So if I'm suddenly creating flux out of the page, the induced current has to have flux into the page, meaning I use my hitchhiker's thumb and I stick it into the page in the middle of the loop, and then I see which way my fingers curl, which would be clockwise. So I'll say this would induce a clockwise current in the loop according to Lenz's law. So I'm not writing down everything I said. Ran out of space anyway, but essentially, because the B from the wire is out of the page, I need to resist that by sticking my thumb into the page, and then my fingers end up curling clockwise. All right, setup number 2. So same thing, everything starts as off, and then when I turn on the power, current's gonna go this way. It's gonna go around this loop. So this blue thing I'm drawing is the current. And then back to the negative terminal. This is the conventional current. All right, so same thing. When I have current flowing through a wire, it's going to create a magnetic field. I'm going to use the rule for the right-hand rule 2 for the solenoid. I know a solenoid is supposed to be hundreds of turns of a coil. This is only one turn, but I'm still going to use the rule. So I'm going to use my hitchhiker's thumb I curl my fingers clockwise around the blue current. And when I do that, my thumb sticks down. So that'll create a magnetic field going into the page. Okay, so let's write that down. When the power is turned on, a current flows through, I'll call it the outer loop, because it's on the outside of the brown coil. In the direction shown, because I drew the arrows there, of the conventional current. So then right-hand rule 2, right-hand rule 2 is used to determine the magnetic field created inside the loop. This magnetic field is out of the page, or sorry, into the page. Therefore, by Lenz's law, the induced current must resist this change. This means that I need to use my hitchhiker's thumb and stick the thumb out of the page to resist the into the page field created by turning the power on. I'm not writing all that down. I'm just going to write the answer at this point. So if I stick my thumb out of the page, my fingers curl counterclockwise. Okay. Why is this induced current only momentary? Why? So that induced current in both of these situations only lasts for the instant that we turn on the power. It'll induce that current, but then that'll be it. There'll be no more current after that moment. And that's because it requires a changing flux. Through the loop to induce a current. So for how long does the flux change? Well, it only changes the instant we turn the power on. If we just leave the power on, the magnetic field will just constantly be there. It will not be changing anymore. So I'll say the flux changes the moment the power is turned on, but stays constant after that. So if we have a constant flux, that's not going to induce any current.